Close your eyes for a moment and imagine this, the night sky stretched above you, quiet and endless, filled with stars that feel both close and impossibly far. Humanity has always looked upward with the same question whispering in our hearts. What is the structure of this vast universe we belong to? It feels so familiar when we see it every night, yet the deeper we look, the more mysterious it becomes. The structure of the universe is not random, not a messy scatter of stars thrown across blackness. It's shaped by patterns, invisible forces, and cosmic balances that we are only beginning to understand. The way galaxies group together, the way space itself bends and stretches, all of it reveals a silent architecture hidden behind the sparkle of starlight. Tonight, we'll drift through this architecture together. Like gentle travelers, we'll follow the thread of how the universe is built, layer by layer, from the silence of empty space to the dazzling beauty of galaxies and beyond. No hard edges, no sudden breaks, just a soft journey into the deepest design of existence. Let's begin with the vast silence that holds everything in place, the silent vastness of the universe. When we speak of silence, most people think of a quiet room, a pause between heartbeats, or the hush of a forest at night. But the silence of the universe is something different. It is so deep, so infinite, that even our imagination struggles to stretch far enough. Space is not just an empty backdrop for stars. It is a boundless ocean, and in its silence, it holds every galaxy, every atom, every whisper of light that has ever existed. The sheer size of this silence is hard to picture. If you traveled at the speed of light, the fastest thing we know, it would still take you 46 billion years to reach the edge of what we can see. And even then, that's not the edge of the universe itself, only the part that light has reached us from since the beginning. The thought alone makes you feel both small and strangely comforted. Inside this silence, stars burn, galaxies collide, and black holes pull matter into invisible spirals. Yet you would hear none of it. Sound cannot travel in space. There is no air to carry waves. All that movement, all that cosmic drama unfolds in perfect, eternal quiet. Silence is not absence. It is the stage on which creation plays its unending play. And within this silence, there are faint traces like fingerprints left behind. Photons, tiny particles of light, move across it, carrying ancient stories. The background glow we see from the Big Bang still drifts here, filling every corner of space with the memory of its birth. Even silence is never truly empty. It hums with invisible echoes, older than time itself. When you pause and picture it, silence in space is not frightening. It's more like a cradle. It makes you realize that the universe is not just about noise and events, but about a stillness so profound that everything has space to exist. The silence of the universe is what allows the structure of reality to unfold. Why the cosmos has no center. It's natural for us to want to find a center. When you stand in a room, there's always a middle. When you look at a map, there's always a point you can trace back to. But the universe doesn't play by those rules. It has no true center, no throne where everything began. This is one of the most disorienting and beautiful truths of cosmology. From any place you stand, Earth, a distant planet or a galaxy halfway across the cosmos, the universe appears to expand around you. It's not because we are special, it's because expansion stretches space itself evenly in all directions, like dots drawn on the surface of a balloon being blown up. Every dot sees every other dot moving away, yet none can point to the exact center of the balloon's surface. This idea changes how we see ourselves. We often imagine Earth as a stage where everything happens and everything points back to us. But the universe has no favorite, no chosen location. Everywhere is equally in the middle, and nowhere is the middle at all. It's a humbling thought, but also liberating. It means the cosmos is balanced in its design. If the universe did have a center, we could measure our distance from it. Civilizations across galaxies would map themselves outward. Instead, every observer writes their map differently, yet the story remains the same. We are all inside a centerless structure, floating together in an expanding ocean. No front row, no back row, only endless horizons stretching forever. And perhaps this is why stargazing feels so personal. When you look up, it feels as if the universe is unfolding just for you. But when another being does the same, light years away, they feel it too. The cosmos has no center, and maybe that is its most generous gift. The fabric of space, stretching like a canvas. Space is not nothing. It may look like emptiness, but in truth it is a kind of fabric, invisible yet elastic, stretched across the whole of existence. Imagine a canvas stretched tight, and upon it stars, planets, and galaxies rest like tiny beads. Their weight bends the canvas, curving it in ways that change how everything moves. But this is what Einstein called space-time. Gravity is not a pull through emptiness, but the bending of this fabric. A planet orbits a star not because it's being pulled like a rope, but because the star has curved the canvas beneath it, and the planet rolls along that curve. In a sense, we are all sliding down invisible valleys made by mass and energy, guided by the unseen hands of the fabric itself. This fabric is not rigid. It stretches, it ripples, it vibrates. When two black holes collide, the shock waves ripple through space-time itself, stretching and squeezing the universe as they pass. For a brief moment, the canvas shivers, and detectors on Earth pick up faint tremors from billions of light years away. We are literally listening to the heartbeat of the universe through this fabric. And the most astonishing part, this canvas is expanding. With every moment, space itself is stretching, carrying galaxies farther apart. It's not that galaxies are flying through emptiness, it's that the emptiness between them is swelling. The fabric grows, and with it, the distances grow too. That's why the night sky looks frozen, but is quietly shifting, stars moving apart across a stretching sea. To picture space as a fabric is to see it as alive, flexible, dynamic. Not just emptiness, but a living backdrop that holds all things. It's the stage, the road, and the unseen current all at once. The fabric of space is what gives the universe its form. Matter floating in an invisible web. When astronomers looked closer at galaxies, they discovered something puzzling. Stars weren't moving as they should. Whole galaxies were spinning too fast to hold together, and by the math we knew they should have torn themselves apart long ago. The only explanation was that something invisible, something massive, was there, holding it all in place. This became known as dark matter. Dark matter doesn't glow, reflect, or absorb light. It passes through stars, planets, even your body without notice. And yet it outweighs the matter we can see by nearly 5 times. That means most of the universe's structure is shaped by something we cannot see, only feel by its pull. Galaxies, clusters, and even the great cosmic web are strung together on its skeleton. Imagine a spider web stretched across the universe and galaxies like dewdrops clinging to its threads. That's how astronomers describe the cosmic web. Dark matter threads through space, creating vast filaments that connect galaxies in patterns eerily similar to neural networks in the human brain. It's as though the universe thinks in threads, weaving connections on scales both microscopic and cosmic. These webs are not static. They tug and shift, pulling galaxies into knots and clusters, shaping their paths like rivers carve valleys. Without dark matter, the universe would look scattered and shapeless. With it, we see architecture, filaments, nodes, and voids that give the cosmos its grand, foamy structure. The invisible web is humbling. It reminds us that what we see is only a fraction of what exists. The glowing stars, the shining galaxies, they are just lanterns strung across threads we cannot touch. The true skeleton of the universe lies in shadow, unseen but undeniably real. The dance of dark energy in empty space. If dark matter pulls, then dark energy pushes. It is the great counterbalance, the mysterious force causing the universe to expand faster and faster. Unlike matter, which clusters, dark energy seems to fill every corner of space evenly, like an invisible mist that pushes galaxies apart. Its discovery in the late 20th century shocked science, rewriting our understanding of cosmic destiny. At first, astronomers thought gravity would slow expansion over time, perhaps even reverse it. But when they studied distant supernovae, exploding stars, they found the opposite. The universe wasn't slowing, it was speeding up. Something in the very fabric of space was driving galaxies away from each other with increasing force. That something was named dark energy. To imagine it, think of a balloon being blown up, not at a steady pace, but faster and faster as time passes. Galaxies ride on its surface carried outward. Dark energy is not a wind blowing them. It is the balloon itself stretching at an accelerating rate. It is everywhere, constant, yet still mysterious enough that we only guess at its true nature. Some say dark energy may be linked to the vacuum energy of space itself, the restless fluctuations of particles popping in and out of existence. Others think it's a property of space-time we have not yet discovered. What's certain is that it makes up about 70% of the universe's total energy content, meaning most of reality is shaped by a force we barely understand. The dance of dark energy reminds us that emptiness is never truly empty. It carries within it a force so powerful it sets the fate of everything. Whether the universe expands forever, tears itself apart, or transforms into something new depends on this hidden energy dancing silently in the void. Galaxies as islands of light. When you look up at the night sky, the stars seem scattered randomly, but they are not wandering alone. Most of them belong to galaxies, vast islands of light floating in the dark sea of space. Each galaxy is a world unto itself, home to billions or even trillions of stars, bound together by gravity and dark matter. To imagine a galaxy is to imagine a city of suns, each with its own planets, moons, and mysteries. Galaxies are breathtakingly diverse. Some are grand spirals, their arms curling like cosmic pinwheels. Others are smooth ellipses, glowing softly like lanterns. A few are irregular, as if sculpted by invisible hands into strange, uneven forms. Each one is a fingerprint of the universe's history, shaped by collisions, gravity, and the delicate balance of forces stretching back billions of years. Our own Milky Way is just one of these islands, though vast enough to make our imagination falter. 100,000 light-years across, filled with hundreds of billions of stars, it feels infinite when you gaze at the sky. And yet, when seen from afar, it would be just a glowing disk among countless others. Galaxies are not solitary wanderers. They group together, drawn into clusters, tied by invisible filaments of dark matter. These clusters form even larger superclusters, strands of light woven through the darkness. Each island of light is connected to others like jewels strung across an endless necklace. The more we map them, the more the universe resembles a living web of fireflies in motion. It's humbling to know that every galaxy could host countless worlds and perhaps countless stories. Our island of light feels so precious because we live here. But in truth, it is one among billions, floating quietly, shining against the dark. The shapes galaxies choose in the dark. When you imagine a galaxy, chances are you see a spiral, arms stretching gracefully outward. But galaxies are not all the same. Their shapes tell hidden stories about how they formed, what they endured, and how they continue to evolve in the shadows of time. The universe has allowed galaxies to sculpt themselves in three main forms: spirals, ellipticals, and irregulars. Spiral galaxies, like our Milky Way, are young and active. Their arms are nurseries where stars are born from vast clouds of gas and dust. The bright blue glow of young stars winds outward, giving spirals their shimmering, elegant form. They look alive, like whirlpools of light, frozen in space. Elliptical galaxies are older and quieter. Shaped like stretched spheres or elongated eggs, they have little gas left to form new stars. Instead, they glow with the warm, reddish light of ancient suns, nearing the ends of their lives. They are the elderly guardians of the universe, holding the memory of earlier times in their silence. Irregular galaxies defy neat categories. They have no symmetry, no predictable form, often twisted and scattered by collisions with larger neighbors. They remind us that the universe is not tidy but creative, sculpting beauty out of chaos. Even in their odd shapes, there is a lesson: destruction often gives rise to new beginnings. The shape of a galaxy is not permanent. Over billions of years, spirals may merge into ellipticals, irregulars may be tamed into order. The cosmos is an artist with endless patience, painting and repainting its canvases in forms of light. Spirals, ellipticals, and the odd ones out. To understand galaxy shapes more deeply, think of them not as separate categories, but as stages of life. Spirals are the energetic youth, full of movement and starbirth. Ellipticals are the elders, stable and calm, glowing faintly with their ancient stars. Irregulars are the wild ones, shaped by chance, refusing to follow patterns. Together they form a cycle that tells the story of cosmic growth. In spiral arms, gas clouds collapse into stars, while gravity tugs them into neat, rotating disks. Over time, spirals collide with each other, merging their arms, scattering their stars, and eventually settling into elliptical forms. It is like watching cities grow, merge, and transform into quieter towns, their earlier activity preserved only in memory. Ellipticals can be enormous, some of the largest galaxies in the known universe. Their mass swallows smaller galaxies whole, incorporating them like rivers merging into an ocean. These giants are quiet in appearance but ruthless in growth, dominating their cosmic neighborhoods until only a few remain to rival them. Irregulars tell a different tale. They are reminders that not every life is orderly. Some galaxies are stretched, warped, or shredded by encounters with larger systems. Yet even in their chaos they shine, often bursting with star formation, lighting up like fireworks against the black. Their unpredictability is part of their charm. Each type of galaxy is a glimpse into time itself. Spirals show us the present, ellipticals show us the ancient past, and irregulars remind us of the unpredictability of the future. Together, they make the universe feel like a grand symphony of forms. Superclusters, binding galaxies together. Galaxies are vast, but they rarely exist alone. They cluster, drawn together by gravity, forming families that number in the hundreds or thousands. But these families themselves are not the final scale. Clusters gather into even larger structures called superclusters, spanning hundreds of millions of light years. To picture them is to imagine cities of galaxies stretching across unimaginable distances. Our own Milky Way belongs to the local group, a cluster of around 50 galaxies. And this group is part of the Laniakea supercluster, a structure containing over 100,000 galaxies. It's almost impossible to picture, like trying to imagine every grain of sand on Earth gathered into glowing spheres of light and arranged in a cosmic tapestry. Superclusters are not random collections. They are held together by invisible dark matter filaments, strands of gravity that act like cosmic highways. Galaxies flow along these highways, drawn toward larger centers of gravity. The supercluster itself has no solid edge, just a fading boundary where its pull gives way to the next structure. What's fascinating is that superclusters appear to form patterns across the sky. When astronomers map them, they see threads and knots weaving together, resembling a vast web or even the structure of living tissue. It is as though the universe itself is alive, pulsing with clusters connected across unfathomable distances. In superclusters, the scale of the universe begins to overwhelm. A single galaxy, enormous on its own, becomes just one bead on a thread among thousands. And yet, it is this very binding that gives the universe its grand design, tying everything together into one living whole. The Great Cosmic Web. The largest structure we know in the universe is not a galaxy, not a supercluster, but a web. The cosmic web is the true skeleton of the cosmos. Filaments of dark matter and gas stretching billions of light years, with galaxies glowing faintly along its threads like fireflies. This web is what gives the universe its shape, vast and intricate. When astronomers map the sky in 3 dimensions, galaxies do not appear scattered. Instead, they trace filaments forming long chains connected at intersections called nodes. Between these filaments lie enormous voids, regions where almost no galaxies exist. The result looks like a sponge or the froth of soap bubbles frozen on a cosmic scale. This web is not static. Gravity pulls matter along the filaments, feeding galaxies with fresh gas and dark matter. Over billions of years, clusters grow at the nodes, like drops forming where threads meet. The cosmic web is both map and engine, shaping the growth of galaxies and feeding them with the raw material of stars. What is most mysterious is how similar this web looks to other patterns in nature. Neural networks in the brain, the root systems of trees, even the delicate veins of leaves, all echo the same design. It raises a quiet question. Is this web just physics, or is it part of a deeper language of nature, repeating itself across scales? The cosmic web is a reminder that the universe is not random chaos. It has a structure, vast, intricate, and delicate at once. And in this structure we see both our insignificance and our belonging, connected to a design far greater than ourselves. Filaments that stretch across billions of light years. Imagine a thread so fine you could barely see it, yet so long it could stretch across the entire observable universe. That is what cosmic filaments are like, rivers of dark matter and gas, billions of light years long, threading galaxies together in strands that look almost alive. These filaments are the highways of the universe, channels through which matter flows and galaxies are fed. Galaxies rarely form in isolation. They trace these filaments, clinging to them like glowing beads. Matter drifts inward along the threads drawn by gravity, collecting into massive knots where clusters of galaxies grow. In a way, filaments are like the veins of a living body, carrying the raw material of creation through the cosmos. The scale is beyond comprehension. A single filament can be hundreds of millions of light years thick and extend billions of light years in length. And yet, from a distant perspective, they form delicate patterns, faint lines etched across the darkness. They are massive and delicate at once, a paradox that seems to define the universe itself. Filaments also tell us about time. They grew from the tiniest ripples left over from the Big Bang, stretched out by cosmic expansion and pulled into shape by dark matter. To study them is to peer back into the universe's childhood, seeing how the faintest shivers of energy became grand, enduring structures. When you imagine these filaments, picture them glowing faintly in the dark, galaxies strung along them like pearls. It is here, along these colossal threads, that the universe we know took its form. Voids where almost nothing exists. Between these filaments lie the opposite, vast empty regions called voids. They are enormous bubbles of almost nothing, stretching hundreds of millions of light years across. When astronomers map the universe, these voids look like hollow spaces, surrounded by webs of galaxies. It's a reminder that emptiness is just as much a part of the universe's design as matter itself. In a void, galaxies are sparse, sometimes only a handful, scattered across an unfathomable distance. Stars there are lonelier, with fewer neighbors shining nearby. If you lived inside such a galaxy, your night sky might feel strangely dim, with fewer points of light piercing the blackness. The sense of isolation would be profound. Yet these voids are not meaningless, they balance the web. Just as silence shapes music, emptiness shapes structure. By having regions where matter is absent, filaments can grow more defined. The contrast between filled and unfilled space creates the cosmic foam we see when the universe is mapped in 3 dimensions. Voids also hold mysteries. Some theories suggest they might be sensitive places where new physics could be hiding. Because they are so empty, tiny forces, like the effects of dark energy, might reveal themselves more clearly here than in crowded regions. In a way, voids are laboratories of the cosmos, waiting for us to listen carefully enough. Emptiness, when stretched to this scale, no longer feels like absence. It feels like design. The voids remind us that the universe is built as much from silence and space as it is from stars and galaxies. Why the universe looks like foam in reverse. If you've ever seen soap bubbles cluster together in a sink, you already know what the large-scale structure of the universe looks like. The filaments form the thin walls, galaxies gather along the edges, and the voids are the empty bubbles. The only difference is that in the universe, the walls glow with light, while the bubbles are hollow. It's like looking at foam turned inside out. This resemblance is not just poetic. When astronomers chart galaxy positions, the patterns are striking. Thin filaments crisscross space, enclosing vast, hollow voids. The foam-like pattern repeats on every scale we can measure, from a few million to billions of light years. It is a fractal design, endlessly echoing itself across the cosmos. The similarity to everyday patterns is fascinating. Nature seems to repeat certain designs, whether in soap, crystals, or galaxies. Some scientists believe this hints at universal principles, where the same mathematical rules guide structures from the microscopic to the cosmic. Others simply marvel at the beauty of the coincidence. To imagine the universe as foam helps us picture the balance between emptiness and fullness. Just as bubbles press against one another to form stable shapes, galaxies press against voids, creating the web. This balance, delicate and grand, is what keeps the universe structured rather than chaotic. It's a comforting image in a way. When you wash your hands or watch bubbles float, you are seeing a faint reflection of the very design that holds galaxies together. The universe looks like foam in reverse, fragile yet eternal, delicate yet vast. The strange balance of gravity and expansion. At the heart of the universe's structure lies a quiet tug-of-war. On one side is gravity pulling matter together, forming galaxies, clusters, and filaments. On the other is expansion, driven by dark energy stretching space itself apart. The structures we see are the result of this delicate balance, neither side winning completely, but shaping reality in partnership. Gravity alone would collapse the universe into knots and clusters, dragging everything together into dense balls. Expansion alone would scatter galaxies too far, leaving them unable to form stars or planets. Yet the universe has managed to balance these forces so precisely that both structure and growth are possible. This balance changes over time. In the early universe, gravity dominated, pulling gas and dark matter into filaments and galaxies. But as space expanded and dark energy began to dominate, the balance shifted. Expansion now has the upper hand, stretching the universe faster than galaxies can grow together. Still, the scars of gravity remain in the structures we see today. It is this tension that gives the universe its shape. Galaxies cluster because of gravity, but clusters drift apart because of expansion. Voids widen, filaments stretch, yet within them stars continue to form. The push and pull create a rhythm, like a breath, contraction and expansion woven into cosmic time. This strange balance may one day decide the universe's fate. Will gravity slow expansion, or will expansion scatter everything until even clusters fall apart? For now, the balance is just right for us to exist, a fragile harmony that feels almost intentional. How galaxies don't tear apart despite the push. If the universe is expanding, you might wonder why galaxies themselves don't stretch like taffy. After all, if space is growing, shouldn't everything inside it be pulled apart? The answer lies in the strength of gravity on smaller scales. Within galaxies, gravity is strong enough to bind stars together, resisting the expansion of space. So while the cosmos grows, galaxies remain whole. This is why you and I don't feel the universe's expansion in our daily lives. On the scale of humans, planets, and even solar systems, gravity and other forces are far stronger than expansion. It is only on the scale of millions or billions of light years that expansion shows its hand. Galaxies are like boats floating on the surface of an inflating balloon. The surface grows, pushing the boats farther apart. But the boats themselves don't stretch because their own structures hold them together. In the same way, galaxies move away from each other, but the stars inside them remain bound in a cosmic embrace. Dark matter plays a crucial role in this stability. Its invisible mass surrounds galaxies like halos, anchoring them even more tightly. Without it, galaxies might not withstand the gentle tug of expansion. With it, they remain coherent islands of light, floating apart but never unraveling. This resilience of galaxies is one of the universe's quiet miracles. Expansion pushes, but gravity holds. Stars continue to orbit, planets continue to spin, and life continues to bloom, even as the space between galaxies grows wider with each passing second. Stars as the building blocks of galaxies. Galaxies shine not because of their size, but because of the stars inside them. Stars are the true bricks of the cosmic cathedral, the tiny flames that add up to make galaxies visible. Without stars, galaxies would be skeletons of dark matter, invisible and silent. With them they glow like lanterns in the vast dark. Every star begins as a cloud of gas and dust collapsing under its own gravity. In the furnace of its heart, hydrogen fuses into helium, releasing light and heat. Multiply this by hundreds of billions and you get the brilliance of a galaxy. Each star is small on its own, but together they make galaxies shine across billions of light years. Stars give galaxies their character. Young galaxies burst with hot blue stars, glowing fierce and bright. Older galaxies fade into a soft, reddish glow, filled with ancient suns nearing their ends. The light we see is not just illumination. It is a clock, telling us how long a galaxy has been alive and how it has aged. Yet stars are more than decorations. They recycle matter, forging heavier elements in their cores. When they die, they scatter these elements into space, seeding new generations of stars and planets. Without them, there would be no worlds, no water, no life. Every atom in our bodies was born in the heart of a star. So when you look up and see the faint band of the Milky Way, remember this: you are looking at a river of stars, building blocks of galaxies, and the very ancestors of your own being, the mysterious weight of dark matter holding them. If stars are the bricks, dark matter is the cement. Galaxies spin far too quickly for their visible stars and gas to hold together. Without extra mass, they would fly apart. The missing weight, unseen but undeniable, is dark matter. It surrounds galaxies in vast halos, invisible but powerful, binding them like invisible scaffolding. We cannot see dark matter directly. It doesn't shine, reflect, or absorb light. But we feel its presence in the way galaxies move. Stars on the outer edges orbit too fast to be explained by visible matter alone. Something unseen keeps them tethered, as if galaxies float in invisible cocoons of gravity. This mysterious weight is 5 times greater than all the stars and planets we know. In other words, most of a galaxy's mass is hidden. The glowing parts we admire are just the tip of an iceberg, while dark matter is the vast hidden bulk beneath the surface. Galaxies shine like lanterns, but their strength comes from shadows. Dark matter doesn't just hold galaxies together, it shapes the universe. It pulled matter into filaments after the Big Bang, guided galaxies into clusters, and built the very skeleton of the cosmic web. Without it, the universe would be scattered and formless, a mist instead of a structure. The mystery is not yet solved. What is dark matter made of? Particles we have not yet discovered? Something stranger still? For now, galaxies remind us that even what is unseen may be more important than what we see. The invisible halos that surround galaxies. Every galaxy you see is not alone. It is wrapped in an invisible halo of dark matter. These halos extend far beyond the stars we can observe, sometimes 10 times wider than the visible galaxy itself. Think of them as protective cocoons, silent guardians that shape the way galaxies form, move, and survive. Halos are not static shells. They are dynamic, filled with dark matter particles swirling in ways we cannot detect. The gravity sculpts the paths of stars, stabilizes galactic disks, and even protects galaxies during collisions. Without halos, galaxies would be fragile, torn apart by the push and pull of cosmic forces. Evidence of halos comes from gravitational lensing, the bending of light around massive objects. When astronomers observe distant galaxies, they see light distorted by invisible halos along the way. It is as if the halos leave fingerprints on starlight, reminding us of their presence without ever showing themselves directly. These halos may even influence where new stars form. By pulling in gas from the cosmic web, they feed galaxies, ensuring the cycle of creation continues. They are not passive shells, but active participants in the life of galaxies, guiding them like unseen hands. When you gaze at a spiral galaxy, glowing beautifully in a telescope image, remember this: what you see is only the heart. The true body of the galaxy lies hidden in its halo, stretching far beyond the light, unseen but essential. Black holes as anchors of cosmic cities. At the center of almost every galaxy lies something darker than dark. A black hole, millions or even billions of times the mass of our sun. These are not destructive monsters, but anchors, holding entire galaxies steady, shaping their growth and feeding them bursts of energy. They are the invisible hearts of cosmic cities. The gravity of a supermassive black hole is extraordinary. It bends space and time, drawing in gas, dust, and stars. As matter falls inward, it heats up, glowing brighter than anything else in the universe. Entire galaxies can be lit by the energy from these central engines. But black holes also regulate galaxies. Too much gas could create uncontrolled star formation, but black holes release bursts of energy that blow excess gas away, balancing the galaxy's growth. In this way, they act like gardeners, pruning and shaping the galaxy to keep it alive for billions of years. The Milky Way has its own central black hole, Sagittarius A, about 4 million times the mass of the Sun. It is quiet now, but in the past it may have blazed brightly, feeding on gas clouds and shaping our galaxy's destiny. Even now it anchors the orbits of stars at the galactic core. To think of black holes as anchors, not destroyers, changes everything. They are the silent cores around which galaxies gather, the unseen heartbeats of the largest structures in the universe. Quasars lighting the early universe. Billions of years ago, the universe was darker than it is now. But in that darkness, some galaxies lit up like cosmic lighthouses. At their centers, supermassive black holes consumed matter so furiously that they outshone entire galaxies. These blazing beacons are known as quasars, the brightest objects in the cosmos. Quasars are powered by black holes, but not just any black holes. These are giants billions of times heavier than the Sun, devouring gas at incredible rates. As the matter spirals inward, it heats up, glowing so brightly that its light travels across billions of years to reach us today. In the early universe, quasars lit up the darkness, marking the end of the cosmic dark ages. Their light helped ionize the gas that filled space, allowing the universe to become transparent and stars to shine freely. Without quasars, the universe might have remained hidden in fog for much longer. Quasars also acted as cosmic signposts. Their brilliance allows us to study the distant universe, giving us clues about how galaxies grew and how black holes formed so early. Each quasar is like a message in a bottle, carrying news from a time when the universe was young and wild. Though fewer exist today, the memory of their brilliance lingers. To picture the early cosmos is to imagine a dark sea pierced by the light of quasars, lighthouses guiding us through the ancient night. Cosmic microwave background, the universe's baby picture. Imagine the universe as an infant, just 380,000 years old, a blink compared to its 13.8 billion years today. In that moment, it gave us its first photograph, the cosmic microwave background. This faint glow stretched across the sky is the afterglow of the Big Bang itself. It is not a light we can see with our eyes, but radio antennas reveal it as a soft hiss, a glow that surrounds us on all sides. This radiation carries secrets. Tiny ripples in its temperature, just fractions of a degree, show us where matter was slightly denser. Those denser spots grew into galaxies, clusters, and the cosmic web we see today. In that baby picture, we see the seeds of every star and planet that would ever exist. The glow is astonishingly uniform. No matter where you look, it looks the same, differing only by tiny ripples. This uniformity tells us the universe began hot, dense, and remarkably smooth. And yet, without those tiny imperfections, there would be no structure, no galaxies, no us. Flaws were not mistakes, they were the fingerprints of creation. The cosmic microwave background is everywhere. Even when your TV shows static, a tiny part of that noise comes from this ancient light, older than the first stars, older than the first galaxies. Every day we are bathed in the echo of the universe's birth, though we rarely notice it. To look at this glow is to look backward through time itself. The universe has no scrapbook, no written history. But it gave us a baby picture, a faint, beautiful whisper of where it all began. Ripples that became galaxies. In that first glow of the cosmic background, we see ripples, tiny variations in density, like faint wrinkles on a newborn's skin. These ripples, unimaginably small, would one day grow into the grand structures we see today: galaxies, clusters, superclusters. From the tiniest tremors of energy, the universe built cathedrals of light. Gravity was the sculptor. Where there was slightly more matter, gravity pulled in even more, creating denser regions. Over millions of years, those regions collapsed into clouds of gas. Over billions, those clouds became galaxies. From faint ripples in the beginning, the architecture of the cosmos emerged. What's striking is how precise this balance was. If the ripples had been too small, gravity would never have overcome expansion, and the universe would remain a thin mist. If they had been too large, everything would have collapsed into black holes. Instead, they were just right. Delicate imperfections that allowed complexity to bloom. These ripples are recorded in the cosmic background like a frozen memory. When astronomers study them, they see the first outlines of today's universe. They are the blueprint of all that followed. Every galaxy, every star, every atom of your body can trace its roots back to those tiny wrinkles of light. It's extraordinary to realize the Milky Way, Earth, and all of us began as a faint ripple, a whisper in the early glow of the cosmos. From almost nothing, everything came to be. Inflation, stretching the early cosmos beyond imagination. Before the universe gave us its baby picture, something astonishing happened. In the tiniest fraction of a second after the Big Bang, the universe expanded faster than the speed of light in an event called inflation. From smaller than an atom, it grew to cosmic size almost instantly. A balloon inflated to unimaginable proportions in less than a heartbeat. This inflation smoothed everything out. It explains why the cosmic background looks so uniform, why space is so flat, and why the universe on large scales looks the same in every direction. It was as if the universe ironed itself out in a single, explosive breath. The concept sounds impossible. How could something grow faster than light? But it wasn't matter moving through space faster than light. It was space itself expanding. Nothing traveled across it. The fabric itself stretched. It's like dots on a balloon moving apart, not because they're racing, but because the surface itself is growing. Inflation also magnified the tiniest quantum fluctuations, the jitter of particles at microscopic scales, into the seeds of galaxies. The reason the universe has structure at all is because inflation stretched quantum whispers into cosmic ripples. The smallest scale became the largest design. To think of inflation is to touch the edges of imagination. In less than a blink, the universe grew from nothing to vastness, and in that expansion, the blueprint for everything we know was drawn. Why the universe looks uniform from afar. Stand far enough away from anything, and it looks smooth. A forest looks like a blanket of green, though up close it is trees and branches. The universe is the same. From a distance it looks uniform, almost featureless. Galaxies evenly sprinkled, light stretched evenly across space. This uniformity is one of its most puzzling and beautiful qualities. The cosmic microwave background proves this. No matter where we look, the glow is the same, with only tiny ripples. Galaxies, too, distribute evenly on the largest scales. The universe has no patchy clumps when viewed as a whole. It is surprisingly even, like a perfectly woven fabric. This is astonishing, because at small scales, the universe is anything but uniform. Stars cluster, galaxies collide, clusters form knots, and voids stretch vast. But zoom out, and those contrasts vanish into smoothness. The chaos is only visible up close. From afar, the design feels calm and ordered. This balance may come from inflation. By stretching space so quickly, inflation evened everything out. The result is a cosmos that, though wild and chaotic on local scales, looks harmonious on the grandest stage. It's like a painting where brushstrokes are rough, but the whole picture is serene. The uniformity is comforting. It means that no matter where you stand, on Earth, on a distant star, or in a galaxy unknown, the universe looks the same. We all share the same view, the same fabric stretched across the sky. The role of time in structuring space. We often think of space as something separate from time, but the two are woven together. The structure of the universe is not just about where things are, but when they are. Time flows differently depending on gravity, motion, and expansion. It bends, stretches, and shapes the very fabric of space itself. Einstein's theory of relativity showed us that massive objects curve space-time, and time itself slows near strong gravity. This means the structure of the universe cannot be drawn on a flat map. It must include the flow of time. Galaxies are not just positioned in space, they are layered in time. When we look at distant galaxies, we are not seeing them as they are now, but as they were millions or billions of years ago. The farther we look, the further back in time we travel. Telescopes are not just windows into space, they are time machines letting us watch the universe write its story page by page. Time also shapes how structures evolve. Stars live and die, galaxies grow and collide, clusters drift apart. Each moment leaves imprints on the fabric, weaving time into the design of the cosmos. Without time, structure would be meaningless, frozen, lifeless. To see the universe's structure is to see time itself written in starlight. Every glowing point in the sky is both here and then, a reminder that the cosmos is not static, but alive, unfolding with every passing second. Why looking out is looking back. Every time you raise your eyes to the night sky, you are not only looking outward, you are looking backward in time. Light does not travel instantly. It has a speed, though fast, still finite. The light from the moon is 1 second old. From the sun, it's 8 minutes old. From the nearest star, 4 years. The farther we look, the deeper into history we peer. This means telescopes are not just instruments of distance, but of time. A galaxy 10 million light-years away shows us what it looked like 10 million years ago. A quasar billions of light-years away shows us the universe when it was still young, fiery, and wild. The night sky is not a snapshot of now, it is a layered mosaic of the past. There's a quiet wonder in realizing this. When you see the faint glow of a star, it may no longer exist. It may have burned out ages ago, but its light is still arriving, carrying its memory across space. To gaze at the heavens is to witness ghosts of ancient suns still shining long after their deaths. This time delay is not a flaw, it's a gift. It allows us to study the history of the cosmos as it unfolded. Astronomers don't just theorize about the past, they see it written in starlight. The universe carries its diary with it, page after page of glowing light, waiting to be read. So when you look at the night sky, you are not simply looking outward, you are traveling back through ages, seeing the universe as it once was, billions of years before you ever opened your eyes. The universe is a history book of light. If time is woven into space, then light is the ink that records it. The universe is a history book written in photons, carrying stories across unimaginable distances. Every ray of light that reaches us is a letter in that book, describing where it came from and when it began its journey. Galaxies write their stories in soft glows. Supernovae record their lives in sudden bursts, brief but brilliant. Quasars blaze their chapters with furious energy. Even the cosmic background is a page, the first faint entry in the diary of existence. Each wavelength, from radio to gamma rays, carries part of the story. Astronomers are the readers of this book, decoding the language of light. By splitting it into colors, they learn what elements are present, how fast objects are moving, even how old they are. A single spectrum is like a fingerprint, a paragraph in the tail of a star or galaxy. Light doesn't just illuminate, it speaks. The beauty is that the book is endless. With every improvement in telescopes, new chapters appear. We find faint galaxies at the edge of visibility, adding new entries to the record. The deeper we look, the older the book becomes until we approach the very first page written by the cosmos itself. To think of the universe as a history book is to feel connected. We are not separate readers, but characters written in its pages. Our story is part of the same light, still being added with every heartbeat. Why some stars die to feed the next ones. Stars may seem eternal, but they are not. They live, they age, and eventually they die. And yet their deaths are not ends but beginnings. When stars explode as supernovae, they scatter the heavy elements they forged into space. From that debris, new stars and planets form. Without death, there could be no renewal. Our Sun, for instance, is powered by fusing hydrogen into helium. Larger stars go further, creating carbon, oxygen, silicon, even iron. But when they reach iron, they can no longer generate energy. Gravity crushes them, triggering a colossal explosion. That explosion flings enriched matter across the galaxy, seeding the raw material for new generations. Every atom of iron in your blood, every atom of calcium in your bones was made in the heart of a dying star. Without stellar death, life as we know it could never have existed. In the cycle of stars, we see the cycle of life itself, repeated on cosmic scales. There's a certain poetry in knowing that endings are necessary for beginnings. Stars give their lives so others may shine. Galaxies glitter not because stars are eternal, but because they are constantly reborn. The night sky is a balance of deaths and births woven together into a tapestry of light. The structure of the universe depends on this recycling. Without it, galaxies would dim, planets would never form, and the cosmos would remain sterile. The death of stars is not a tragedy, it is the secret of creation itself. The endless recycling of matter in the cosmos. Matter in the universe is never wasted. Like water flowing through rivers and clouds, it cycles endlessly. Stars form, live, and die, scattering their material back into the galaxy. Gas clouds gather it, collapse again, and new stars form. It is a rhythm billions of years old, still continuing all around us. Nebulae, those glowing clouds we admire in telescope images, are often the remains of dead stars. The Crab Nebula, for example, is the remnant of a supernova seen on Earth nearly 1,000 years ago. Its glowing filaments are gas and dust that will one day become part of new stars and planets. Even black holes, which seem to consume everything, play a role. Their violent activity can trigger star formation in nearby clouds, recycling energy into new beginnings. Nothing is truly lost. Even in destruction, something new is set in motion. The recycling happens on every scale. Planets form from the dust of stars, moons from the dust of planets, comets from leftovers of solar systems. Every object is second-hand, every atom has been used before. You are breathing oxygen that once cycled through countless stars and worlds before finding its way into your lungs tonight. This endless recycling makes the cosmos not a static place but a living one. Nothing is wasted, nothing forgotten. The universe is a master of reuse, sculpting beauty out of its own ashes again and again.